So students, welcome finally to the last part of today's class. You see how long these numericals are, series solution. You see it took me 15 minutes class actually. Not 5 actually, 4 because the first one I only showed you the method. So we needed 4 for the numerical, but slowly I'm sure you will be able to fasten things. We are able to accelerate things a bit. So we have been here actually while equating the coefficients of x to the power 0, we arrived at this one which we named as A. Equating coefficients of x to the power 1, that is x, we arrived at this, and equating coefficients of x to the power n, we arrived at this, which we named as capital A, and we called it the recurrence relation. Now when I put n is equal to 2 here, I am repeating this portion because we seem to be in a hurry towards the end of the class. So when I put n is equal to 2, 2 plus 2, 4 here, c n minus 1 means c 2 minus 1, so it is c1. Since I put here n square, this will be 4, so this is 4, and this is c2, so this is c2. And this is 2 plus 1, 3, and 2 plus 2, 4. So this is 3 multiplied by 4, and which implies that C4 is equal to C1 by 12. It's C1 by 12. So we had equation A, B, C, and let this be how much? Let this be equal to CAB, not C, so this is C. So we have A, B, C. We'll use all of them to find the solution at last. So this we did by putting n is equal to 2. Now again, putting n is equal to 3 in A. So we are putting n is equal to 3 in A, and see what do we get. When I put n is equal to 3, this gives me C5. We get that C5 is equal to C3 minus 1 is C2, C2 minus 3 square is 9, so I get here 9 C3 divided by 4 into 5, which gives, that implies, what is C5? C5 is equal to look at this one. Now this is C2 and C3. We already know what is C2. C2 is 0, is it not? So C2 is 0, so it is just minus 9 C3 by 20. So can I not write it as 9 by 20 into C3? And what is C3 here? It is C0 minus C1. I think I should have written a 1 by 6 here, it will come. So it is into 1 by 6 C0 minus C1. So this is my C5, and which can be written as, or C5 is equal to, when I do this, this becomes 3 by 2, so it is minus 3 by 40 C0 minus C1. So this is my equation number C. This is my equation number D. So let me take out some space here like this. Slowly I am getting used to writing on this board. So it's like this. So see what we have now in our hand. We have C2 which is 0, C3 we have, C4 we have, and C5. So let us look at our solution. What was our solution? Our solution was given by A. So using A, B, C and D in A actually I should have named this as 2A, the solution, which I named as A. I'm speaking about that one, that y is equal to, we had assumed this solution n goes from 0 to infinity Cn x to the power n. This was the solution. Let us assume that the solution is this. We had assumed that this will be the solution, and when I open it, what do I get? I put this is C0 x to the power 0 plus C1 x plus C2 x squared plus C3 x cubed. Let us write till 5 because we have the constants till 5. We could have calculated more but not required. So C4 x to the power 4 plus C5 x to the power 5 plus up to infinity. So here what we do is we put the values like this. C0 will remain as C0, C1 as C1x plus what was C2? C2 was 0, so we have a 0 here, plus what is C3? C3 is 1 by 6 C0 minus C1 into this will be 3 x cubed plus what is C4? C4 is nothing but C1 by 12, so is C1 by 12 x to the power 4 plus we come to C5 now. And what is C5 now? C5 is, if I should write, I think I should drop this plus sign. It comes as a negative number. It has a negative sign. So C5 is, so it is minus 3 by 40 C0 minus C1 plus dot 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 remains like this. So let us see, look at all the constants. Even if you would have calculated C5, C6, C7, C8, you would have found that they are all functions of C0 and C1. You will find that each of the constant becomes a function of C0 and C1. So when I separate them as the terms containing C0 and C1, then I get something like this. I get this as 1 plus, we have a C0 here, C0 here. Again look at this one, comes x cubed by 6. So C0 here, this is the C0, so it is plus x cubed by 6. Again we have a C0 here, which is minus 3 by 40. This will be multiplied by x to the power 5. This term has to be multiplied by x to the power 5 because I just wrote only the C5 value. I have not put the x to the power 5 here. So minus 3 by 40 x to the power 5 plus, and so it goes like this. Now look at the terms containing x, not x, C1. So we have plus C1. If I take common, we have x, this one, then C1, then we have this one which is minus 1 by 6 x cubed, then again we have this one which is plus x to the power 4 by 12, plus from here again we have a C1 which is plus minus minus plus 3 by 40 x to the power 5. So you see we have terms which will go dot 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 dot. So the thing that I want to say you is like this. It is C naught, an infinite series containing x, and C1 plus C1, an infinite series containing x. So if I write it as suppose f1x, I will not write it. We must remember that this I have written only to show you what it means, and this is f2x, where f1 and f2x are not just functions of x, they are actually infinite series. This function, if it is a function, it has to have a finite number of terms, but you see what is happening here. They are all, although they are, each term is a function of x, they are infinite series. So you see, this is the solution and this is an approximate solution. So series solution just gives an approximate idea about the function, and this is the series solution of a differential equation. And compare it with, let me write somewhere here, if I take out a little bit of space out here, when I have a differential equation having two terms, when I have a second order differential equation, what I have that the solution y is a function of x plus b a function of another function of x, like this. So it's like this. Here, in case of infinite solution, and when do we require infinite solution? When this type of normal kind of a solution is not possible. So we take this long and laborious method. We are to learn them, but then why it is required? Because nowadays we have computers, and these things can be very easily done in a computer. You make a program and feed it to the computer, and you get an approximate solution. And you see, this happens in most physical problems, because physical problems, they do not have a direct answer, don't have a direct solution. You may have things like this. So from our next class we'll do one or two more numericals, but then it takes up a lot of time. So I'll guide you and I'll give you some study material where worked examples are done. So after this we'll go to something very specific, that is called the Frobenius method. Frobenius method is a particular type of method for solving series solution. And I promise you it's not going to be short. From now on, for a few classes, we'll have very long solutions. We have to solve numericals. But what we have to do, we have to do. If I have to write on this board, I have to write. If I have to record my chapters, my lectures, I have to. So there's no running away from it, because you can't run away from your exams. You will have to sit for your exams. You have to go forward in life. So I'm happy that some of the students are going along with me. They are doing numericals. They are asking me questions. So, but for others who are not doing that, they will be in trouble. Okay, thank you for having the patience to sit through the class.